Welcome back to my channel, everyone. We are back with another tutorial of systems of equations. In this video, we are going to be learning substitution, elimination, and we are also going to be going through a few word problems. So let's just get started. So substitution is actually a method to solve a system of equations algebraically. In the last part, we learned how to graph the equations and then solve them that way. But this way is a little bit faster because we don't have to graph it, plug in different values, and then find where they intersect, if they intersect. And for substitution, there are 4 main steps, but we're going to do an example right now that will help you understand. So we have x plus 4y equals 6 as one of our equations, and then we have 2x minus 3y equals 1. Let's do this first step. Isolate one variable in either equation. You can choose either, but let's choose the simpler looking one. So let's go with this one. So we have x plus 4y equals 6. Now let's isolate x since it doesn't have a coefficient. So x, this is very simple, x equals 6 minus 4y. Just moved it to the other side. Now we're going to move on to step number 2. Substitute that value into the other equation. So that value that we're referring to is this whole thing, this whole expression. We're going to substitute it into x because we're saying that x equals 6 minus 4y. So this whole thing is going to replace x in this equation. This will become 2 times 6 minus 4y minus 3y equals 1. And now we're step number 3, we're going to solve for that variable, meaning y, because now we took out x. There's no more x in the second equation, so now we're solving for y. So 2 times 6 is 12, 2 times 4, y is negative 8y, minus 3y equals 1. Now we're going to collect like terms, so negative 8y minus 3y plus 12 equals 1. Negative 8 minus 3 is negative 11y plus 12 equals 1. Move 12 to this side. Let's continue over here, and we have negative 11y equals 1 minus 12. We have negative 11y equals 1 minus 12 is negative 11. Obviously divide both sides by negative 11, and then you get y equals 1. But we're not done yet. Now we're moving on to step number 4, which is the last step. We have to actually go back to the first simplified equation, which is this one right here, and plug in the value of y, so 1, into the y in that equation. So let's rewrite the equation here. We have x equals 6 minus 4y, and then we put in 1 for y. So x equals 6 minus 4 times 1. That gives us 6 minus 4, and that gives us 2. And that's our solution. That is where the 2 equations will intersect at 2, 1. And that is how you solve a system of equations with substitution. Another important thing to remember is substitution is often your first attempt, because elimination is another method that we're going to go over in a few seconds to also solve it algebraically, but you typically want to attempt solving using this method, substitution, unless you're explicitly told to solve with elimination. If you can't isolate any of these, like in the very first step, if you're not able to isolate a variable without it becoming a fraction, then you use elimination. Now we're going to move on to our second method of solving system of linear equations algebraically. And this one is a tiny bit more complicated than substitution. So pay very close attention with what I'm actually doing and make sure you understand why I'm doing them. Otherwise, it will be hard. Start off with step number 1, which is the most complicated step because it's the only new step compared to substitution. So the whole idea is to cancel out one of the variables. And what I mean by that is, if the two equations we had were 3x plus 4y equals 29, right? The same first equation. But the second equation, instead of being 2x minus 5y, if it was negative 3x minus 5y equals negative 19, the x's, the 3x, could cancel. So we could literally add these two equations, and then that would result in x becoming 0. It doesn't exist. That's basically what we want. We want one of these variables to be gone. But sometimes, like in this scenario, nothing will cancel because none of the numbers are the same. Like we don't have 3x and negative 3x. We don't have 4y and negative 4y. Now, before I choose different numbers to multiply these equations with, I have to decide which one is my goal. Do I want to cancel out x or do I want to cancel out y? And it does not matter. You can choose either or. It literally does not matter. So let's just say for this case, I want to cancel out x. So I look at the numbers, I'm like, okay, 3x and 2x. What can I multiply both of these numbers with to make them the same? And I can actually multiply them with each other. So that means this first equation I'm going to multiply with 2, and this equation I'm going to multiply with 3. It has to be negative 3, because I can only cancel out if the signs are opposite. If they're both positive, they're just going to end up adding. So one has to be positive and one has to be negative for x. Okay, so now I'm going to multiply it. 2 times 3x is 6x. 2 times 4y is 8y. And then 2 times 29 is 58. Okay, so that's my new equation. Now I have to multiply this second equation by negative 3. So negative 3 times 2x, negative 6x, which is exactly what we wanted. And then negative 3 times negative 5y is 15y. And then negative 3 times negative 19 is 57, I believe. Okay, so we're done step 1. Now we are at step 2. There will only be one variable to solve for. And yes, there is, because now these two will cancel out. The x's will cancel out, and now we'll only have y. But we have to add them so that the x's actually cancel out. So 6x plus negative 6x, 0, gone. No more x. 8y plus 15y, 23y. And then 58 plus 57, 115. Okay, and then we divide both sides by 23. Y equals 115 divided by 23 is 5. Alright, now we have completed step 2. We have solved for the remaining variable. Now we know what y is. And now we're going to do what we did for substitution and literally just substitute that y into one of the original equations. Okay, so we can choose either of them. I'm going to choose to substitute it into this equation, but you could also choose the second equation. It doesn't matter. So then we have 3x plus 4 times 5 equals 29. Now we only have to solve for x because now y has a value. So 3x plus 20 equals 29 minus 20 minus 20. 3x equals 9. Divide both sides by 3 and we get x equals 3. And that is our final solution for this question, 3, 5. And you would have gotten the exact same answer if you chose to eliminate y in the first step. Now we are moving into the last section of this video and also this unit, system of equations, and that is word problems, everybody's favorites. A cell phone company offers you 2 different plans to choose from. Plan A costs 30 cents per text, and Plan B costs a one-time fee of $15 and then 10 additional cents per text. Now the first part of this word problem is to create a system of equations that can be used to calculate the cost of each plan depending on the number of texts. And then after that we have to solve and explain which plan is better. We need to choose our variables. Okay, so we need to choose a variable for number of texts, because that's what it depends on, and also a variable for the cost of each plan. Okay, so since we usually do y equals, we'll say y is equal to the cost of each plan, and we'll say x is equal to the number of texts. Now we have to look at each plan, okay? So let's start with plan A. We are creating a system that can be used to calculate the cost, which means it will be y equals, like the cost equals. And plan A says 30 cents per text, which means we obviously want our answer in dollars, because cents would be kind of insane. We would end up with like a million billion cents and have to convert that into dollars, right? So let's just choose to work with dollars instead of cents. So 30 cents in dollars is 0.3. $0.3 is 30 cents, right? So 0.3 times the number of texts. So x, right? Because 30 cents per text, which means $0.3 times x, because x is the number of texts. And that will give you the total cost. But let's move on to plan B. So in plan B, costs, you have a cost of one-time fee of $15 and then 10 cents per additional text. Again, this whole equation is to find out the total cost, so y equals. And we're working with dollars. So the $15 is fine. We have a one-time cost of $15. So we have 15 plus 10 additional cents per text. So 10 cents in dollars is 0.1 or 0.10, whatever, same thing, times the number of texts, so x. Okay, so those are our two equations to calculate the cost of each plan depending on the number of texts. All right, now moving on to step 2, we have to solve and explain which plan is better. You can either graph it if you want and then find where they intersect, and that would be the solution, right? Or you can do it with substitution or elimination. So let's do it algebraically with substitution. So we have y equals 0.3x and we have y equals 15 plus 0.1x. Don't even need to isolate a variable because they're both already isolated. And now we're going to put this whole thing into y in the second equation, okay? Because I don't have to isolate, they're already isolated. Y is already on its own. So I'll go with the first one. I put that value into the second equation. So now that replaces y, because y equals 0.3x. So now I replace this here, 0.3x equals 15 plus 0.1x. And then I solve. I have 0.3x minus 0.1x, because I moved this to the other side, equals 15. 0.3 minus 0.1, 0.2x equals 15. Divide both sides by 0.2, and I get x equals 75. Okay? And then again, I'm not done yet, because now I need to solve for a value of y. Okay, so then this gets resubstituted into this equation. So then we have y equals 0.3 times 75 instead of x, and that gives us 2250. Our solution is when x is 75 and y is 2250. Now, this part is really important for you to understand. Which plan is better and why, and how exactly do you know that? Like, you have your solution now, 75 and 2250, but what does that mean? And how do you know which plan is better, right? Well, you have to go back to what exactly does x mean and what does y mean, right? So 75 is x, and that is the number of texts, right? 2250 is y, which is the cost, right? So now you know your solution is when the number of texts is 75 and the cost is 2250. And now you have to actually think about it. What does the solution mean? When you're graphing it, it's the point where they intersect, right? It's the point where they are the same. They are equal to each other, which means when you send 75 texts, for both plans, the cost will be $22.50. Think about it graphically. They intersect at 75, when x is 75. This is where they both intersect at this point exactly. But you have to think about plan A is y equals 0.3 times x, which means x is 1, y is 0.3 times 1. When x is 2, y is 0.3 times 2. So you have to think about the slope. Which way is it going? And they're both going upwards, but at different rates, right? Plan A is going like this. But plan B starts at 15 because of the y-intercept here. It starts at 15. So let's say 15 is over here. 15. It starts there and it goes up slowly, 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 slowly. And they both meet here. So plan A is better if you are sending less than 75 texts. But if you're sending more than 75 texts, plan B only increases slightly each time. But plan A is increasing a lot more, because you can see that when you graph this, plan A, the second you send 76 texts, plan A is more expensive than plan B. The cost is going to increase more. All right, so that was my tutorial on system of linear equations, and we are done with this unit. I really hope you guys found this helpful, and I will see you guys next time.